Swayam Prabha. Digital India. Educated India.
So can I have 2 volunteers on stage, please? Can I have 2 volunteers on stage? You. Yeah. Okay, stand here. Okay, and stand there, face the audience. And what you have is a 3-dimensional line in your hand, and raise your both hands. And orient this line in any way you can. Yeah, it's good now. Statue. Do the same. Anyway. Yeah. And statue. Okay. So we were discussing auxiliary method last time. So we were given a 3-dimensional line. Of course, we are working with sketches on 2-dimensional paper, and we essentially have the front projection, or the projection of a 3-dimensional line on a vertical plane and the horizontal plane. So what's your name? Siddharth. What's yours? Neeraj. So Siddharth and Neeraj are volunteers who are holding 2 3-dimensional lines in different ways. What you see is essentially the projection of Siddharth's line on the frontal plane and Neeraj's line on the frontal plane. Okay, and imagine that this projection looks like this. And if you get a chance to develop wings, and if you tend to fly, and if you tend to hit the roof, you would essentially be seeing the top view of these projections. All right, so now the question is, how do I find the true length of this 3-dimensional line given the 2 projections, which are what you see on the screen? Okay, so what I have over here on the right is a little 3-dimensional box where, of course, this projection, okay, all right, so this projection is on the horizontal plane and this projection is on the vertical plane. Okay, and if I extend the 2 projections, I would be in a position to get the 3-dimensional line in a box. All right, so somebody asked me yesterday, well, I mean, what is the use of doing all that exercise that we have been doing, because we have been able to capture this line anyways within a box. Okay, so the answer to that is, well, have you actually captured, can you actually see that 3-dimensional line? No. Although the box is something that you can see, it's still visible on a 2-dimensional vertical plane, right? It doesn't help. Anyhow, what do? So the idea is okay, so maybe I'll probably need one more. Can you come? Yeah. Purple t-shirt, yeah. The GC. Hold on. Number 5. Yeah. I don't know your names, I'm sorry. As much as I would want to know your names. Okay, so stand in front of Neeraj. So, Shashwat, Shivam. Shashwat and Shivam are able to see the frontal projections of these three-dimensional lines. Okay. Now, what they would do is, to get the true picture of the line, they would try to reorient themselves. Okay. Now, can you try to reorient themselves so that you can see the actual three-dimensional line? Yeah. You're okay. You're okay. Can you see that? No? Can you? Yeah. Now can you see? Okay. How about you? No. You have to. Yeah. What have they done? What have they done? If you look at that red plane over there, they have essentially oriented themselves to be parallel to that plane. Okay? Isn't that true, Shivam? Yeah? Now, once they have oriented themselves to stay parallel to the plane on which, or on a plane parallel to which that projection lies, and therefore the actual three-dimensional line lies. Once you have captured that plane, all you need to do is draw a hinge line and flip that plane over. As simple as that. Okay? Everybody with me here? Okay, can I over? Yeah, over. Statue over that game. Okay. Clear? Now, stay with me here. Stay with me. This is important. So, that red plane is actually a plane that's parallel to another plane which is containing this projection as well as this actual three-dimensional line. So, once you have captured both of these, okay, all you need to do is flip that plane over like you do in case of orthographic projections. Okay? So, these distances are the same because that red plane is parallel. Okay? So, you have, and then what would this distance be? Would it be the same as this distance? Great. How about this one? The same as this distance? Right? Okay. All you need to do is now figure out, so this is the true line that you have captured on the plane. Figure out the hinge lines and flip this red, what we call the auxiliary plane, over. Okay? As far as visualization goes, this should be now clear to you. Okay? You know, wait. I'm running behind in schedule and I need to do this. Okay? Because otherwise you'll have problems with your next lab. So I need to do this. So extra class Friday 12 to 1 L17. Feel free if you want to come, great, I'll be there. If you don't want to come, fine. So what we'll do now is we'll flip this plane over with respect to this horizontal plane. Okay? This is the hinge line that separates the vertical plane from the horizontal plane. That's the blue line. Stay with me. Now, if you notice this purple hinge line, this one has to be parallel to the projection in the horizontal plane. Okay? Right? Yeah? Okay. And of course, the projections are going to be perpendicular to the hinge line. Now, pay attention to this distance we are trying to flip this plane over. So what would this distance be over here? So should I be measuring this here or here? Here? Okay. And likewise, the smaller green distance, I measure it there, and I have this green line capture, a red line captured there. So essentially what I've done is I have rotated this red plane above the hinge line, maintaining these two distances as this and this. Okay? And I have the true length of the line on the auxiliary plane. Do you agree? Do you agree? Good. The easier way to remember this is this. This is how I remember. You essentially have three views of the line: the frontal view, the top view, and the auxiliary view. Okay? Which view is common? Which view is common? The frontal, the top, or the auxiliary? The auxiliary. Sorry, the top view is common. So this one is common between this view and this view. Okay? Now, just in case if you are confused where to take the distances from, this would help. Just let go of the common view, measure the distance in one of the given views, and transfer that distance in the third view. Okay? As simple as that. Okay? Now let's see if you can exercise this in a slightly different manner. Now I really do not need to have the auxiliary plane associated with the horizontal plane. I can have it associated with the vertical plane as well. This is of course in true length. Hinge line that separates the front from the horizontal or the top. Okay, this is something that we have seen. It doesn't really matter where the distance of that hinge line is from the projection. We'll essentially be getting the same. We'll essentially be getting the same true length of that line. Okay, this was the line that was parallel to the line from before. Now, hinge line. Now, instead of drawing a hinge line which is parallel to the projection in the horizontal plane, I'm going to draw my hinge line over here. Same concept. Same concept. Okay? Then what? Have the projections come out perpendicular from which view? Horizontal or vertical? Vertical. Like these? Okay? Now, this view is going to be common. This view is going to be common between this view and the auxiliary view. Okay? Where are you going to be measuring the distances from? From the horizontal. So you would measure this distance there, and these distances have to be from the hinge line. Okay? These distances, they have to be from the hinge line. So you would be measuring that distance over there and transferring that distance where? Left projection or the right projection? Left projection or right projection? Huh? This one. Again, this would be measured from this hinge line. Measure that distance in the horizontal plane, again from the hinge line, and transfer it over there. And you have the true length. Now, if you go back to your method of rotation, and if you go even further back, I had introduced certain formula, right? So if one of the projections is horizontal or rather parallel to the hinge line, then the other projection is going to be giving the true length of the line, right? Right? Do you see something very similar over here? Do you see something very similar over here? This projection is parallel to this hinge line, and therefore the other projection will be giving the true length of this three-dimensional line. And this is going to be true in case of auxiliary plane as well. Right? With me? With me? All right. Now, in this one, we had taken the auxiliary plane from the top view, the vertical plane, and the other example, we had done the same thing from the from the vertical plane, or from the front view. They both give you the true lengths of the line. Are you convinced? Would the length be the same or would it be different? Same. Just in case if you're not, if I transfer this line over there, okay, and draw an arc, this confirms it. Okay? So whether you use the top view or the front view, okay, draw the auxiliary plane from there, get the true length, it will be the same. So far with me? So far with me? Okay. Now, Shivam. Okay. Choose any orientation, stand somewhere. Okay, all right. The first thing Shivam did was to orient himself in such a way that he captured a plane on which the actual three-dimensional line was there to get the true length. Okay? Now, the question is, if I want to get the point view of a line, in other words, if I want to orient myself to a plane where I can see the point, okay, corresponding to this line, what would I do? Yeah. How would you see the line as a point? Yeah, statue. Stay there. That's how. Precisely that's how. Okay? So he is looking at, or he is on a plane which is so he is on a plane which is perpendicular to the line. Okay? So I have a plane where I capture this line in true length. Now I have to look at this line from a direction perpendicular to it. Okay? For that, what do I need to do? If I want to draw a hinge line and flip that plane over, where would my hinge line be? Where would my hinge line be? This guy in true length, if I want to get the point view of this, where would my hinge line be? Perpendicular to this. Okay? Yeah. Okay? And the same concept of transferring distances. Now, this view becomes common between this view and the view that we are going to draw. Right? And we are going to be transferring distances. We are going to be transferring distances from where to where? From the top view to the second auxiliary view. This is the first auxiliary view, this is the second auxiliary view. Okay? And do you now kind of see whether we are going to be getting a point? There will be a single projection. There will be a single projection here, right there. And we are going to be measuring distances from the top view. And these distances, they will be the same. And I need to transfer that distance over there. And essentially, I'll be seeing the point view of a line. Agreed? Agreed? No? Why not? Huh? this distance is the same as that distance. 3 views, 2 views are associated with a single view. Okay, drop that view, take the distances from the first view, transfer them to the third view. 3 views, 1, 2 and 3. This view is common between this and this. Drop this view, okay, take the distances from here and transfer it over here. Yeah? Lost? Now, do you agree that if I draw a hinge line perpendicular to the true length view of the line, okay, here, and if I take a projection here, somewhere over here I'll be seeing the point view of the line. Do you agree with that? Do you agree with that? Yes, sir. All right. Where would that point lie? Where would that point lie? Where would it lie? I mean, you're following the same steps, right? You're creating another auxiliary plane, aren't you? Aren't you? So the principles that we have learned from before of transferring distances, you're going to be transferring distances from this view to this view, right? Where is this point? Where is this point? Take this distance, transfer it over there. Same principles, right? Questions?
So can you go back to the box diagram and show where the black hinge line lies with respect to?
There. Can you come here? Well, you have to see it for yourself. Take this. Go over there. So the red line, which is the true length of a line, that lies on the red plane. This one, absolutely. Okay? So if you want to get the point view of this line, absolutely. Absolutely. So
If I make this my black
so your black hinge line will be perpendicular to this one. Rather, yeah, it would be lying on the plane which is perpendicular to this. Won't it? Won't it? So if my plane that contains the true length is here, okay, how would you orient to get the point view of this? You'll have to go perpendicular over there, right? Let me see if I can explain this better. So as far as visualization goes, so how would you, where are you? Yeah, how would you describe this hinge line? With respect to, let's say, this hinge line. So what you have done is you have flipped the auxiliary plane from this hinge line, right? So your auxiliary plane was kind of here somewhere, you just kind of flipped it over, right? Now this plane is kind of down here, and you're flipping this up like this. So remember, you're working everything on a two-dimensional plane. So when you flip, you transfer distances, right? Okay, I can do the same thing from the other side. So remember, I had taken this hinge line over here. I had associated this auxiliary plane with the frontal plane. If I want to draw the point view of a line, okay, then I have to figure a hinge line which is perpendicular to the TL line, right? Take a projection which is perpendicular to the hinge line and then transfer distances. Now from where am I going to be transferring distances? From where am I going to be transferring distances? From here. So this distance is the same as this distance. Okay? So if I transfer this distance over here, okay? So this guy is sitting over here somewhere. Okay? And this guy is just behind this guy. Okay? But the same distance from the hinge line. This is the point view. Think about this. So this guy, so these 2 points are one behind the other. These 2 points are one behind the other. Which one is closer to you? The one which is closer to the hinge line. Yeah? And this is right at the back. So if you imagine that this is pretty much like the true length, okay, and if you kind of flip it like so, you see this point, okay, and then you see this point exactly or precisely behind this point. That's what the point view is. Yeah? With me? A little lost? Completely lost? Okay. What's that? I can't hear you. I can't hear you. Why did we take this distance the same as this distance? Okay. This example, okay? Your true length is going to be lying on these projections. Why are we taking this distance the same as this distance? Why? Why? Yeah, so if you go back to that three-dimensional box, you will kind of make that relation, right? So those distances they're going to be the same. You do the same exercise and you'll get your answer. Do the same exercise, you'll get your answer.
Which two planes intersect to give that black line? Can you show it in the cube? Like which planes intersect to give that black line?
Yeah? Which two planes intersect to give the black line? You have the answer right there. You have the answer right there. Shift this plane back, let it pass through the blue projection line over there. So this plane will be containing the black line. So the blue line, oh, we'll probably have to work out the cue for that. Okay? Perhaps I'll do that tomorrow. Okay? For now, just take my word for it. But it shouldn't be very difficult. I mean, so once you have this true line over here, imagine that this is there on the frontal plane. Okay? Now what? Now what? You're going to be looking at a plane which is perpendicular to this line, and then you're flipping that plane over. On this plane, you are going to be seeing the point view of the line. Huh? You're flipping this plane over. Same thing. But I'll try to explain it better tomorrow, perhaps. Anyhow, so if this is not clear, maybe take my word for it. I'll try to do a better job tomorrow. I was here somewhere. Yeah. All right. So just take my word for it, but you are essentially doing the same exercise, nah? You are essentially doing the same exercise of transferring distances. It'll come with practice. Okay. So an example. Okay, this is a little difficult for you to understand. So you have the projection on the frontal plane. You have the projection on the horizontal plane. Front view, the top view. Okay. And this is something that you would need to keep in mind. That if there are 3 views, okay, just ignore the common view. Take distances from one and transfer them to the other. So take distances from the views which is not common. From the view which is not common. Okay. So for example, this is the hinge line that separates these 2 projections. Maybe it'll be a nice idea for you to sketch this while I'm working with it. So you'll probably get a better idea. All right. So what I'll do is I'll draw some arbitrary hinge line somewhere here. Okay? Stay with me here. Eyes on the screen, please. What I'll do is I'll draw an arbitrary hinge line. Okay? Ideally, I should be drawing this hinge line parallel to the projection, but I'm trying to make a point. So I'll draw this hinge line arbitrarily. Okay? In a sense, I'm free to choose the auxiliary plane that I want. I am, frankly speaking. I can view that line or that projection from anywhere I want. Okay? Follow that rule. Take distances. So this view is going to be common. This view is going to be common. The distances are available from here. Okay? And of course, if I'm viewing these 2 vertices, my projection lines, they have to be perpendicular to this hinge line. Right? I take the distances from below, okay, and transfer them over there. Okay, I get one vertex, I take the distance from that vertex down there and transfer it over here. Okay, I get 2 vertices, I get a line. Okay, let me go forward. I'll take another arbitrary hinge line. Again, this is not parallel. Now, this guy is common between the view that I'm going to be making and this view. So I'm going to be taking the distances from this one here and transferring it over here. Okay? And this time my projections are going to be perpendicular to this hinge line. Like this, like this. I take this distance, transfer it over there, this distance, transfer it over there. I get some other projection. Okay? All right? Just a so to speak, physical exercise. Okay? Not even mental. Now, if I draw a line or a hinge line which is parallel to this projection, do the same exercise. Now, this time this view is common, so I'll have to take the distances from here, transfer them over there. Okay, I take this distance, this distance, transfer over there, that distance, transfer over there, I get this projection. Now here, notice that the hinge line is parallel to one of the projections, so therefore you would expect this to be the true length of the line. Okay? Okay, what I did in one go over here, had I taken this hinge line to be parallel to this projection, I would have gotten the true length of the line immediately. But I prefer to take a few steps. I ensure that these hinge lines, they are not parallel to any of these intermediate projections. Okay? Essentially, I was free to choose the auxiliary plane that I wanted to. I'm just trying to make a point. I'll essentially be getting the true length of a line whose vertical and horizontal projections are given over here, right? Now, let me call it TL1. Had I done this in one step, had I made my hinge line parallel to one of these projections, okay? Now, this view is common between this and the view that I'm going to make. I would be transferring this distance over here and this distance over here. I would expect this to be the true length of the same line, because my hinge line is now parallel to this projection. Let me call it TL2. One shot, multiple shots, I should be getting the same result, isn't it? So this is my TL2, this is my TL1, okay? Same orientation, TL1, TL2, and if I let one of the vertices of these two lines coincide, draw an arc, I confirm that I'll be getting the true length of the line. Okay? All right? With me? So what was initially a mental exercise now becomes a physical exercise. You can switch off your minds and, draw this blindly. Yeah? So the point was that I don't need to use just one auxiliary plane. I can use as many auxiliary planes as I want. But of course, that is not going to be efficient. Anyhow, next one. Instead of one line, now let's say we have two lines whose projections are given in the vertical and horizontal planes. Okay? Now V, the subscript V is for vertical, the subscript H is for horizontal. Two lines whose projections are given on the vertical plane and the horizontal plane. Okay, question. Do they intersect? Do the actual lines intersect? They may or may not. How do you know? And how do you find that, whether they intersect or not? How do you find whether they intersect or not? Two lines here. If they're intersecting, if you happen to look at the point view of one of the lines, that has to lie on the other line, right? If you look at the point view of one of the lines, that has to lie on the other line. If it doesn't, they're not intersecting. If the point view of one of the lines is not on the other line, that means that they're not intersecting. Okay, let's confirm. Hinge line, follow these steps carefully. I choose to figure out the true length of CD, line CD, and that's the reason why I am going to be making an auxiliary plane where this projection of CD is going to be parallel to this hinge line. Okay? I'm just focusing on CD. Draw my projectors perpendicular to this hinge line. Okay? This view is common, so I measure distances from here, transferred over here. Okay? Now this is the projection where C would lie, and this is the projection where D would lie. Which distance am I going to be taking? This one? Great. Transfer it there. Okay? Now I'll take this distance and transfer it there. Okay? This is CD. Is this in true length? Why? because one of its projections, this one is horizontal or is parallel to this hinge line. So, you would expect C1 D1 to be in true length. Okay. Now, to get the point view of that, you have to draw a hinge line which is perpendicular to this. But before that, I have to transfer these 2 points as well, just like I did C and D. Okay. So, my AB, they are going to be lying on these projectors which are perpendicular again to this hinge line. Okay. This view is common. So, I measure distances from here, transfer it over here. So, I take this distance, okay, measure this over here. This is my A1, for example. I take that distance, transfer it over there. That is my B1, and that is the corresponding projection of A1, B1. Now, A1, B1 will not be in true length, because of course, this guy is not parallel to this. Yeah. Now, once I have this scene, which pretty much corresponds to one of the lines being in true length and the other one not being true length, you still see the projection of that line. Okay. So, this guy is in true length, this guy may not be in true length. Okay. Now, what I would do is I would just turn myself and have you look at one of these lines in point view. Yeah. This was what the previous scene was. Now, this would be the new scene, rather this would be the new scene. So, that this line would be in point view. Now, for that, you would draw a hinge line which is perpendicular to what? C1 D1. Okay. Now, C1 D1 view is common. So, you are going to be measuring distances from where? From the horizontal plane. Take this distance, and both these distances, they are going to be the same. So, take that distance, and this would be the point view of line CD. Which one is going to be closer to you, C or D? D would be closer to you. Yo. True length. This is your plane where you would be seeing the point view. Yes? All right. Do the same exercise for AB. Okay. Now, take distances from where? From the which plane? From which plane? Horizontal plane. Take that distance, transfer there, take that distance, transfer it there. This is your A2, B2. Auxiliary plane 1, and therefore the subscript 1. Auxiliary plane 2, and therefore subscript 2. Now, do you figure if the lines are intersecting or not? You know that. They don't intersect because the point view of CD does not lie on the corresponding projection of AB. Okay? Another thing, slightly modified example, the same exercise. Hinge line, and this time I am going to be going a little faster. Hinge line, a hinge line which is parallel to CHDH. Okay? Projectors, measure distances from, yeah, transfer there. This distance, transfer there. This is C1 D1 in true length. Do the same thingy for AB. Take the projectors perpendicular to this hinge line. Okay, measure distances from here, transfer there, measure this distance, transfer there. You get the corresponding projection of AB, say A1, B1. Now, C1, D1 is in true length. So, if you look at a view perpendicular to it, you will get the point view of C1 D1. Hinge line perpendicular to that, measure this distance, transfer it there, you get the point view of CD. Okay, do the same thing for A1 B1, measure this distance, take that distance, transfer it over there, you get A2 B2. Now the point view of CD lies on A2 B2. That means that these two lines in space, they intersect. Okay. Okay? Yeah? Hold on. Clearly, this is the point of intersection. If you project it back, this is where your intersection is happening. If you project that back onto the top view, this is where the intersection is happening. And if you project that down, okay, this is where the intersection is happening. Okay? So, just by looking at this view and realizing that the point of intersection over here and over here, if they lie on the projector or projection which is perpendicular to this hinge line, only then the two lines will intersect, otherwise they won't. So, in the first example that was not the case. In the second example, these two corresponding intersections, they lie on the same vertical projection. Yeah? A little test. Yes, your question. Done? Okay.